My dear friends, welcome to Rajshekar classes on applied data science with Python. This is lecture number 383. In this lecture, we will try to understand loss function, hinge loss based interpretation. Just recall our previous lectures. What is logistic regression? Logistic loss plus regularization. Linear regression, linear loss plus regularization. Support vector machines, hinge loss plus regularization. In SVM, we will prove instead of logistic loss or linear loss, if you have special type of loss called hinge loss. Hinge loss plus regularization, you will get support vector machines. Just see this diagram, x-axis, on x-axis what we have, yi into f of xi, isn't it? On x-axis we have yi into f of xi. What is this f of xi? In the case of support vector missions, f of xi is w transpose xi plus p. Let it be Zi. I am assuming this yi into w transpose xi, w transpose xi plus p as Zi, isn't it? This is on x-axis, on y-axis you have loss, isn't it? Now, if Zi is greater than 0, this one, if Zi is greater than 0, then the data point xi is correctly classified. Because why it is correctly classified? Because of yi and w transpose xi plus b have same sign. If they have same sign means what? Correctly classified. Is yi is actual label. This is actual label. That may be positive or negative. This is predicted label. Predicted label. If both are positive, this product will be positive. If both are negative, this product will be positive. Why? If your actual label is same as your predicted label, I can say it is correctly classified point. In the case of correctly classified point, this yi into w transpose xi plus b will be positive, isn't it? What does it mean? Just see this. If zi is greater than 0, I can say xi is correctly classified. When zi is negative, when zi is less than 0, your xi is incorrectly classified. Just let me recall what is 0-1 loss. In 0-1 loss, you will give it is loss of 1 when point is incorrectly classified. When it is loss of 1, point is incorrectly classified. Incorrectly classified. When the point is incorrectly, let me repeat, you will give it a loss of 1 when the point is incorrectly classified, and loss of 0, a point is correctly classified, isn't it? That is 0-1 loss. We realized that 0-1 loss is not continuous at 0, isn't it? This 0-1 loss is not continuous at 0. Since it is not continuous at 0, it is not differentiable. Just we will go to Wikipedia page on Wikipedia loss page. This is Wikipedia loss page. This is the page for loss function for classification. So this blue line, what is this blue line here? Yes, this blue line, this one is, this blue line is 0-1 loss. This is 0-1 loss, isn't it? The brown line that you see, the brown continuous line you see is actually this loss is, what is this? This is logistic loss. Logistic loss, isn't it? Logistic loss. What about other curve? Other curve means what? Now the purple line, this one is hinge loss. Hinge loss, isn't it? This particular curve is called hinge loss. See, both hinge loss and logistic loss, both hinge loss and logistic loss are approximating 0, 1 loss, isn't it? So if you notice, just say this one, hinge loss. What is this hinge loss? Just this is hinge loss, isn't it? This is hinge loss. Yes, it is a straight line from -infinity to 1, isn't it? This is hinge loss. This hinge loss is straight line from -infinity to 1. This is straight line. Just see, this is straight line, isn't it? And from 1 onwards, hinge loss becomes 0. Just see, from 1 onwards, this 1 onwards, your hinge loss becomes 0. Let's write down hinge loss. Hinge loss is straight line from -infinity to 1. It's a straight line from -infinity to 1. After that, it becomes to 0. If you notice, hinge loss straight line is not differentiable at 1. Just see, this is not differentiable. This hinge loss is not differentiable at 1, isn't it? What is the reason? It's not differentiable at 1 because your line is like this. Why it is not differentiable? Your line is like this here. Just see, at this point, line is like this. At this point, it is not differentiable. It is continuous. It is continuous, of course. Just see, it is continuous, of course, but it is not differentiable because it is not smooth curve. This is not smooth curve. Not smooth curve, isn't it? Not smooth curve. Smooth curve. If it is smooth curve, I can say it's continuous. Smooth continuous curves can be differentiable, isn't it? If it is smooth curve, I can say it is differentiable. It is continuous but not differentiable. How does your hinge loss behave? Let's look at from the perspective of ZA. What is ZA? Just let me recall what is ZA. This is ZA. ZA is yi into W transpose xi plus b, isn't it? We are taking ZA on x-axis. ZA is nothing but yi into W transpose a. If ZA is greater than or equal to 1, just see, your ZA, if it is greater than or equal to 1, your hinge loss equal to 0. Your hinge loss equal to 0. And when ZA is less than 1, your hinge loss is equal to 1 minus ZA. Just see this one. This is hinge loss. What it says, if ZA is greater than or equal to 1, your hinge loss is 0. If ZA is less than 1, your hinge loss is 1 minus ZA. Imagine this is, let me assume this is 0.5. Your ZA value is 0.5. What is hinge loss? Hinge loss is equal to, this is also 0.5. Your hinge loss is also 0.5, isn't it? Let me assume your ZA value is minus 0.5. Then what is your hinge loss? ZA is minus 0.5 means minus 0.5 is less than 1. Therefore, 1 minus 0.5. That is 1 plus 0.5. That is 1.5. Just see this. This value is 1.5, isn't it? Therefore, what can I say? This is one way of writing hinge loss. Hinge loss can be written as hinge loss equal to ZA is greater than or equal to 1. If then hinge loss equal 0. ZA is less than 1. Hinge loss equal to 1 minus ZA, isn't it? This is max of 0 comma 1 minus ZA. This can be written as max of 0 comma 1 minus ZA. Let me write what does it mean. Just see. Let me write case 1. How will I write case 1? If ZA is greater than or equal to 1, hinge loss equal 0. This is case 1. This is case 2. These two cases are just same as these two cases. Now we will try to understand that. Just see, if ZA is greater than or equal to 1, 1 minus ZA. What is 1 minus ZA? ZA is greater than 1. 1 minus ZA is negative value. Max of 0 comma negative means you will get 0 only. That's what you are getting. Hinge loss equal 0. If ZA is less than 1, 1 minus ZA is greater than 0. Greater than 0 means what? 1 minus greater than 0 means 0 comma 1 minus ZA. What is maximum of 0 comma 1 minus ZA? As 1 minus ZA is greater than 1 minus ZA. Same thing you are getting. Therefore, these two cases are exactly same as these two cases. Isn't it? It is simple and straight. If you look at these two cases, are exactly same as these two cases, isn't it? Hence, hinge loss can also be written as maximization of max of 0 comma 1 minus zi. This is one interpretation of hinge loss, or this is one formulation of hinge loss. This is maximization, max of 0 comma, this max of 0 comma 1 minus zi. I can say it is much more concise way, isn't it? It's concise way of writing, hinge loss. Just try to understand what is hinge loss and its geometrical interpretation. I will continue my discussion on hinge loss in my next lecture also, that is in lecture number 384. Thank you very much.